Next up in our study of chemical reactions, now that we know how to describe them, we know how to write them out, and we know how to balance them. Now we need to know how to identify them and predict the outcomes. Okay, so today what we're going to focus on is the type of chemical reaction. So your goal is just to be able to identify what type of chemical reaction this is. But then tomorrow, your next goal is going to be able to predict what are the outcomes, what will the products be. So this video is going to go over both identifying the type of reaction and predicting the products of a chemical reaction, okay? But your independent work is going to be broken into 2 days. The first day of independent work is just identifying. The second day of independent work is the predicting, because predicting, you got to use a lot of these skills. You got to use your naming rules, being able to check your charges, being able to balance equations. A lot of stuff is going to go into the predicting, okay? All right, so let's go ahead and run through what are these different types of chemical reactions. All right, so the first one we're going to study, and these I'm studying in no particular order. The first one we're going to study is combustion. So first off, what is combustion reactions? This is when you burn a substance in oxygen. Okay, and we know from studying chemical safety earlier on that we have to have oxygen present in order to burn something. Okay, so you're going to produce heat. Okay, so this is sort of what it would look like. You'd have substance A plus O2 is going to create substance B. Okay, your clue. How do you know it's a combustion reaction? Because on the left-hand side of the arrow, you have O2 all by itself. That is your clue. If you see plus O2, you automatically know it's combustion. Okay, you automatically know it's combustion. So here is an example. Okay, CH4 plus O2, you have O2. Okay, it's combustion. Okay, now how about our predicting of products? How do we predict what the products are going to be? Okay, if you are burning something that is a hydrocarbon, meaning what you are burning only contains hydrogens and carbons, then you will always make carbon dioxide and water. Okay, that will always be your products if what you are burning is a hydrocarbon. Okay, all right, so what if you don't have a hydrocarbon? So let's say I want to burn sodium. So here I have sodium plus oxygen. I have that O2, that lets me know it's combustion. What it's going to do is it's going to combine. Okay, where did that little 2 come from? Using those rules, canceling those charges. Sodium charge is +1, oxygen charge is -2. They didn't cancel, so we crisscross get the Na2O. Okay, and now that we've predicted those products, next we have to balance. Okay, so make sure that we are balancing our equations. Okay, all right, but let's do an example where I have a hydrocarbon. So notice I see the plus O2 by itself. Okay, that lets me know it's combustion. So I take a look over here and I see, oh, this is a hydrocarbon. It has nothing but carbons and hydrogens. That means I'm going to make carbon dioxide and water. Okay, carbon dioxide and water. Oh, what do I need to do now? Now I need to balance the equation. Okay, next up, let's do synthesis. So what is a synthesis equation? This is a reaction in which you have the combination of 2 or more substances into 1. So synthesis is combining. Okay, so you take 2 and you make 1. So if you're just trying to identify what type of reaction is this, on the left-hand side, you will have a plus sign. And on the right-hand side, you will not. There's only one thing over there, so there's no plus sign, because they synthesized. They came together. Here is an example. So you have hydrogen plus chlorine creates hydrochloric acid. No plus sign over here, just the 1. Okay, so that is how you recognize synthesis. You have a plus sign on the left and you don't have one on the right. Okay, how are we going to create our products? Okay, if you have something that is ionic, you're going to use those charges to cancel out to get your proper subscripts. Okay, if you have a covalent, well, that's hard to tell, and that is actually beyond the scope of high school chemistry. So I am not going to give you any where you have to predict the products of a covalent synthesis reaction, because that's beyond our scope, okay? So you'll always get ionic. So for example, we have aluminum and we have chlorine. We have a plus sign. And we just have two elements there. So we know that we need to combine them, and we're going to check our charges. So we're going to look at aluminum on the periodic table, that's +3. We're going to look at chlorine, which is -1. Those don't cancel, so we crisscross AlCl3. And then we need to balance. Okay. Next up, decomposition. This is sort of the reverse of synthesis. So this is where you have a single compound that gets broken apart. It decomposes into 2 or more simpler substances. Okay. So for this one, recognizing it, it's the opposite. On the left-hand side, you only have one thing. There is no plus sign. On the right-hand side, you do have 2 things. You have a plus sign. Okay, so it's the opposite of the other one. So that's how you recognize. No plus sign, plus sign. Okay, so here's an example. I have, on this side, I just have water and nothing else. There's no plus sign over here. But over here, it's broken apart and I have a plus sign. That's decomposition. Okay, what about if we're predicting the products and we want to say, okay, what would this produce? Okay, if it is something that is binary, so there's only 2 elements in the compound, then it's simply going to break into those 2 component elements. If you have something more than binary, so you have 3 or 4 elements or more, well, again, that's beyond the scope of high school chemistry, and it's a little bit hard to tell. There's a lot of rules that go into that. So we will never do any of those examples in this class because that's beyond the scope of our course. Okay, so if I ask you to predict the products of a decomposition, I will give you something that is binary, such as this. Okay, so we have one item here. There's no plus signs. There's only 2 elements, so you would just break that into its parts. Okay, so K would be by itself plus Br. Now notice there's a subscript here. Why is that? Because bromine is one of those diatomic elements. Okay, next up, balance your equation. All right, our next type of reaction is called a single replacement. With this one element replaces another in a compound. Okay, and the way that this is going to work is if you have a metal that is alone, it will replace the metal in the compound. If you have a nonmetal that is alone, then it will replace the nonmetal. So like replaces like. Okay, to recognize this one, you are going to have an element that is all by itself. It is not partnered with another element. And then you are going to have a compound. Okay, then the products will see a replacement. So if this is a metal and this is a metal, they will switch. Okay, so the A replaces the B. Okay, and so you see a different element by itself. Okay, so an element alone with a compound, and then it's switched and you have a different element alone now with a new compound. That's a single replacement because one thing replaced one other thing. Let's look at an example. Okay, so we have copper all by itself, and then we have silver nitrate. So this is a compound. And then what happens? Copper is a metal and silver is a metal. So those two are going to switch places. They're going to replace, the copper is going to replace the silver. So then we come over here, we have copper nitrate, and silver is now by itself. Okay, so the copper replaced the silver. Okay. What if we are predicting products and I ask you to predict a product? Okay, if you need to do that, take a look at what is by itself and determine what it is, because that's what it will replace. So if you have a metal by itself, like we had copper, then it will replace the metal in the compound. If you have a non-metal by itself, it will replace the non-metal in the compound. Okay? But this is where it gets a little bit tricky because the element that's by itself must be more active. So in your module in Canvas, I gave you a new document called the Activity Series and Solubility Rules. So you'll need to look at that and you'll need to determine if it is more active. If it is more active, then yes, it will replace, the chemical reaction will occur. If it is not more active, there will be no reaction. Let's take a look. Okay, here we have iron by itself and we have a compound. Iron is a metal, so iron will replace copper. But we have to check the activity series. So hopefully that's something that you will print out and keep with you. Okay, can iron replace copper? If we look at our list, we see that yes, iron indeed can replace copper because iron is higher up on the list. It is more active. So it will occur, and you will see that the iron knocks out the copper. Okay, but let's look at an example like this. Here we have bromine. This is a nonmetal, so it will replace chlorine, a nonmetal. If we check our activity series, we see that bromine is not higher than chlorine. So bromine will not replace chlorine. So in R, no reaction. Okay, so anytime you have a single replacement, you gotta check the activity series that I provided to you. All right, the last one we're gonna look at is double replacement. Here we have the ions in two compounds change partners. So it's a double replacement. Two things are replacing two other things. This is kind of like doing a do-si-do in your test tube. Okay, so the two metals will switch and the two nonmetals will switch. So A and C switch places and B and D. Okay, so now instead of having A and B, you have A with D. Okay, that's a little bit confusing how they switch but they switch partners. Okay, here's an example. Okay, here we have lead with nitrate. We have potassium with chromate. Okay, the two front ones just basically think about them switching partners, switching them around, so that the potassium is now paired with the nitrate and the lead is now going to pair with the chromate. It's the do-si-do. Everybody's switching partners. What are your products going to be? If I ask you to predict products, you are just going to switch those partners. But for the reaction to actually occur, you need your solubility table. Okay, that's that same document, activity series and solubility. I had them together. One product must be insoluble. So you got to read those solubility rules. Okay, so here's an example. If we have lead nitrate and potassium iodide, okay, I'm going to take the PB, that's going to go with the I now, and the K is going to go with the NO3. Okay, now, do I know this works? If I look at my solubility rules, okay, I see it says that all iodides are soluble except for lead iodide. PBI is not soluble, so this will work. This will happen. What about this one? Okay, the sodium would pair with the iodide, and the potassium would pair with the nitrate. But if I look at my solubility rules, it says that this will not occur, no reactions, because sodium iodide is soluble. All iodides are soluble except for silver, lead, and mercury. This is not silver, lead, or mercury, so that means it is soluble. And then the other one would be potassium nitrate, and it says here that all nitrates are soluble. So neither one is insoluble. So this is no reaction, will not occur. Okay? All right. This is a lot of information. That's why I'm giving you 2 days of independent practice. The first one, just identify what type of reaction. The second one, predict those outcomes. Okay? That's going to be tough because you have to use your solubility rules. You have to use your activity series. So ask for help if you need it.